Yo, man, what's up? I got my rice bowls. Goes to the people that are hungry. Put some change in here, but I'm gonna juggle them. Ready? Go. Oops. Sorry. Oops.
Ow.
Anyways, I just wanted to do one quick proof for you. We're just going to prove that angle 1, 2, and 3 equal 180 degrees. This is number 26. Don't ask me the page because I'm not sure. But it's given triangle ABC. Prove 1 plus 2 plus 3 equals 180. Ready? Let's go. Triangle ABC is given. In the picture, they showed us these two are parallel. I'm going to show you something right now. If these two are parallel, those two are corresponding and they're going to be congruent because those are parallel. And these two right here are alternate interior. They're going to be congruent because those two are parallel. Okay? So, AB is parallel to DC given from my picture. 2 is congruent to 5. They're alternate interior. 1 is congruent to 4 corresponding. 3 plus 4 plus 5 equal 180. These three angles right here form a line, and when you have adjacent angles, they add up to 180. 3 is equal to 3 reflexive. So if 4 is equal to 1, we got 4 and 1 here. 3 is equal to 3, and 5 and 2 are equal. If those three equal 180, then these three equal 180. So 1 plus 2 plus 3 equals 180 by substitution. Okay, we are going to be talking about if-then statements. If you do your geometry homework, then you will understand the problems. If two lines intersect, then exactly one plane contains them. If x equals 3, then x squared equals 9. The if part, if you do your geometry homework, is going to be called the hypotheses, and we're going to use P as a letter to represent the hypotheses. The second part, then you will understand the problems. We're going to use that as the conclusion. Okay, so they're called conditional statements or just conditional. The general form is if P, which is the hypotheses, then Q. The example would be if x equals 3, then obviously x squared equals 9, right? P implies Q. X equals 3 implies x squared equals 9. P only if Q. X equals 3 only if x squared equals 9. And then Q if P, we switched them. X squared equals 9 if x equals 3. Make sense? Okay, moving along here. I gotta take these glasses off. It's not really too sunny out today. Sometimes statements can be restated in the if-then form. So, a conditional statement, all beagles are dogs. The if-then statement, if an animal is a beagle, then it's a dog. That makes sense. Conditional statement, the diagonals of a square are congruent. The if-then statement, if a figure is a square, then its diagonals are congruent. The conditional statement, the sum of two odd integers is even. In the if-then statement, if two numbers are odd integers, then their sum is even. For example, 7 and 9, their sum is 16. Two odd integers, sum is even. Works. Okay. Counterexample. What's a counterexample? When an example can be found for which the hypothesis is true and the conclusion is false in an if-then statement. For example, is this true or false? I mean, if we have true or false, we have to decide. If it's false, draw a counterexample. If it's true, draw a diagram with a given and prove it. So we're going to show you. A, all isosceles triangles are acute. So that's false because in this example I showed you that this angle is not an acute angle, it's 110 degrees, yet these two are still congruent and they're equal. Okay, so that's an isosceles triangle, but it's not an acute triangle. B, the diagonal of an equilateral quadrilateral are congruent. The diagonals of an equilateral quadrilateral are congruent. Equilateral means all sides are equal. Quadrilateral means 4 sides. So this is true, and to show it, we're going to write a given and a prove. Given quadrilateral ABC. It's an equilateral quadrilateral, so I should have actually had lines on each side. Well, equilateral quadrilateral, it should actually, that's not a good picture because equilateral means all the sides would be congruent. I drew those sides too long. But anyways, prove AC is congruent to BD. So you'd have to prove that these true lines are congruent. Okay, so, oh, I see what the problem is. I should have written equiangular quadrilateral, because an equilateral quadrilateral is a square. And I wrote equilateral quadrilateral. Should have been equiangular quadrilateral. So ABCD is an equilateral or an equiangular quadrilateral. I'm just getting you confused, I'm sorry. We can go over that in class. The converse, what a converse means is if the statement, if P then Q, then the converse would be if Q then P. I ran out of room, so I'm going to give you some converse statements. Some of them are true, it's one way, but not true the other. They're false the other way. So if a figure is a triangle, then it's a polygon. That's true. But if a figure is a polygon, it's not always a triangle. So that would be false. If you said if a figure is a polygon, it's a triangle. That's not always the case, so that's false. Some of them have a true statement and a true converse. Like, if a triangle is equilateral, then it's equiangular. That's true. If a triangle is equiangular, then it's equilateral. That's true too. So you can say that by saying if a triangle is equilateral, if and only if it's equiangular. That means both ways. A triangle is equilateral if it's equiangular, and a triangle is equiangular if it's equilateral. So it has to work both ways. How do we put that with P and Q? P if and only if Q. For example, that means P if Q means equivalent to if Q then P, and then P only if Q equivalent to if P then Q. Let's talk about perpendicular lines and two lines that form right angles. If two lines form right angles, then they're perpendicular. If two lines are perpendicular, then they form right angles. So that's going to be if and only if. Two lines form right angles if and only if they're perpendicular. Two lines are perpendicular if and only if they form right angles. So you're going to go on to do the classroom exercises in class. If you want to get a head start, you can. The key word is isosceles today, because it's a hard word to spell, and I always forget to put the extra S or the C. I always forget with isosceles. So that's the key word. Have a good day. That's a Jonathan word.